All right, welcome to Algebra 1 Lesson 5-8. So it seems like Lesson 5-6 introduces probability, and we talk about the probability that something's going to land on heads or tails. Then the next lesson is relative frequency, and it's the actual number of times that a penny or whatever landed on heads or tails, and then you tell me the relative frequency that happened, and it should wind up close to the probability, especially the more that you do. So now we're going to talk about probability without counting, and so we don't have to be too scared about it. It's basically saying we can determine the probability that something is going to happen based on if it's like we're looking for an area that something's supposed to land in, then we take that area that it's supposed to land in and divide it by all the other parts of the area that it can land in, okay? So let's just do some examples, and I think you'll see that it's definitely related to the other probability, but we're going to be using lengths and area and degrees of a circle. So we're going to do lots of examples, so hopefully you have this handout. It says lesson 5-8 through 5-10 notes. We're just going to go over 5-8 today. So let's go over this example. The first thing we need to remember when we do this one is we need to remember the formula for an area of a circle. And we did a lot of this last year if you were in my Saxon math class. But to refresh your memory, the area of a circle is pi r squared. So pi times the radius squared, all right? And of course you remember the area of a square or a rectangle, you just take length times width. All right, so this example is, so you're supposing you're going to throw this dart at a 24-inch square board containing a target circle, that's this, of an area, a radius of 3 inches. So the radius of this guy is 3, all right? And assuming that the dart hits the board and that it is equally likely to land on any point in the board, what is the probability that the dart lands in the circle? Now, what they're saying is it's not somebody aiming for that circle, because then the probability would be more, it'd be greater that it's going to be the circle if you're a pretty good dart player. We're just saying, it's just like somebody's picking, or a computer's picking random points on this, in this rectangle or square. What is the probability that that point would be in that circle? So what we're going to do is the formula to be is where we want it to land. So that would be the area of the circle over the area of the square, which is all the different points that it can land in. So over the area of square. All right? So to do that, we already discussed that the area of a circle is pi r squared. Pi, and the radius of this circle is 3. Pi times 3 squared over the area of the square, which would be 24 inches times 24 inches. So we'll say 24 times 24. And I did this and used a calculator. So I'm going to simplify this. This is going to be 9 pi, because 3 squared is 9, and then 24 times 24 is 576. If you go 9 times 3.14, divide that by 576, you are going to get 0.049, and then turn that into a percentage. You move the decimal place 2 places to the right, and so it's going to be 4.9%. Is that a high probability or a low probability? That's pretty low. Out of 100 of these dots, only 5 of them, or about 5 of them, are going to wind up in this circle. So this is actually pretty small compared to the rest of the square. So we're trying to hit the area of the circle, and then we divide it by all of the other places where it can go. So let's do this next example. And so it talks about the bulldog and the chain and the yard. A group of children hit a softball into the yard. What's the probability that it lands within the reach of the dog? And the reach of the dog is this circle. Okay, so we're looking to see what is the probability it's going to land in this circle. So that's going to be my top number. So my top number is going to be area of circle. Now it's not always going to be area of circle. It is so far, but it's not going to be. And then we're going to divide that by all the chances, because this ball is going to land in this yard, and we don't know exactly where. It could be anywhere in there. So area of yard. And so the area of this circle is still pi r squared. Pi, and the radius on this one is 12. So pi times 12 squared. And then the area of this yard is 100 feet times 40 feet. 100 times 40. All right, so we have 144 pi, because 12 times 12 is 144. And 100 times 40 is going to be 40, and I add 2 zeros. So over 4,000. All right, well, that doesn't make too much sense, but when we put this into a calculator, we get the number 0.113, and that is a probability, because a probability can also be a number between 0 and 1, but we usually like to see it in percentages. So we can move the decimal place, and we will see that it's 11.3% of a chance that it will end up in reach of the dog, which is the area of that circle. All right, stay tuned for the next 3 questions.